In this part 3 video of Getting Started with GitLab Application Security, we're going to go through the dependency scanning tutorial, setting it up, and then mock resolving a security finding of having an old version of a piece of software that we depend on, hands-on. So let's do it together, shall we? Just as a reminder, we're working our way in this series through the Getting Started with Application Security Testing document. This video in part 3 is all about dependency scanning. I'm going to go ahead and hold down my Option key, click Dependency Scanning to open up Dependency Scanning in a new tab. The document that comes up for dependency scanning is very academic and very wordy, and I have a bias towards doing hands-on, real-world learning type exercises. So if you look on the left-hand side over here, there's a tutorial on setting up dependency scanning. That's what we're going to do on this video. If you want to see me read the doc, the academic doc, that's going to be on the next video. So more than happy to read through that, but let's get hands-on first and read the academic stuff second. All right. To get started, the tutorial, let's set up dependency scanning. Dependency scanning can automatically find security vulnerabilities in your software dependencies while you're developing and testing your applications. Those libraries that you've included in on your Python app, your Java app, your Ruby app, whatever it is. How do you know they're secure? How do you know they're running compliant versions? All those things are dependencies, and we need to make sure that those versions are being kept up to date. For example, dependency scanning lets you know if your application uses an external or open source library that is known to be vulnerable. How many of us, when we start a software project, start with version 0.0.1 of some third-party library, and then by the time we're done coding our project, they've already released a non-beta version of that library you depended on, like a version 1 or a version 2. Wouldn't it be nice if we had something that managed that stuff in the external world that happens without our knowledge? That's what dependency scanning does inside GitLab. You can take action to protect your application, or you can just simply manage the versions of things you depend on. This tutorial shows you how to create a sample vulnerable application. Then, how to detect, triage, and resolve vulnerabilities in the application's dependencies. How to detect vulnerabilities in a merge request. Let's set it up. All right, to set up dependency scanning, we create example application files, triage the vulnerabilities, resolve the high severity vulnerability, test the vulnerability detection in a merge request. All of these links are just simply anchor links to stuff inside this document. So I'm not going to bother clicking on any of these because we're literally just going to walk our way through this document. Prerequisites. Before you begin, make sure you have Gitpod enabled. Gitpod is an on-demand cloud development environment. For details, see Gitpod. Alternatively, you can use your own development setup. In this case, you need to have Yarn and Node.js installed. We are absolutely going to use Gitpod for absolute certain. However, we are not going to follow the directions on how to set up Gitpod, nor are we going to do any of the prerequisites whatsoever. When the step comes to edit a file inside of Gitpod, we're just going to select edit the file. And when I select Gitpod, it will automatically provision up a Gitpod environment for me. So all of this prerequisite stuff, we are skipping the prerequisites entirely because we don't need to do it. Create example application files. First, in a new project, create files to configure your pipeline and add dependencies that can be scanned for vulnerabilities. So this is totally a setup, right? They're going to take a bunch of text files that are included in this tutorial. We're just going to copy and paste those files into my blank project. All right, so first of all, I need a GitLab CI YAML file. So that's the GitLab pipeline file. I'm just going to copy that to my clipboard. Over here on this screen, this is my Getting Started with GitLab Application Security Dependency Scanning demo project. And if you scroll down just slightly, you can see there's one file, a README, and it's just the generic README. So this is an empty project. There's no magic, nothing up my sleeves. I'm going to use the GitLab user interface here to just create that pipeline file. I'm going to click the plus right here in the middle of the screen. I'm going to select New File. I'm going to create the file name right at the top here, pasting .gitlab-ci.yaml. And rather than applying a template, I'm going to copy and paste the actual text right here out of the tutorial and into the contents of that file. Paste. There we go. That's the whole thing. But I'm just going to go ahead and make a commit here on this particular file so that it's on my mainline branch. And commit. Next, I'm going to create a file by the name of index.js. That sounds like a JavaScript file. So again, heading back over here to my code repository or project in GitLab. Again, right here in the middle of the screen, this plus, I'm just going to click the plus and create a new file because it's a super easy way to use the web browser to create it. At the top, I'm going to click in the file name, type index.js or paste that in, and then the contents of the file are going to be nothing more than the contents right here from the tutorial. Copy to my clipboard, paste inside my file, scroll down to the bottom, do a commit. Awesome. Back to the directions. I need a package.json file. And again, just going to copy the file name right here from the tutorial into my repository. I'm going to click the little plus to create a new file in the center of the screen. So I went ahead and pasted in package.json. Right there is the file name. And I'm going to get the contents from the tutorial. Oh, look at this. This looks interesting. I'm going to copy these contents, paste them right here. I would bet that this tutorial is going to have this package name on a particularly pinned version that's probably old and vulnerable. That's going to be my guess. Let's find out if that really happens. All right. Finally, we have a yarn.lock file, which I bet's going to be full of a whole bunch of libraries and dependencies that are also super old and out of date and vulnerable to security vulnerabilities, just so we can do this demo. We will commit our package.json file. And heading back, again, I'm going to create a new file with a plus in the center of the screen. It's going to be called yarn.lock. And for those of you who are not familiar with Yarn or JavaScript packages, yarn.lock is just a way to pin or require specific versions of dependencies when you're developing a JavaScript application. So this is sometimes a safe practice, like in an enterprise environment where you want to maintain a specific version of something so that your JavaScript code can call that particular thing, whether it's a web API, opening up a file, or whatever it is. Maybe your code is dependent on a specific version of JavaScript something or another, and the yarn lock file allows you to pin or stick with a very specific version of a third-party dependency. All right, back to the tutorial. It's going to say use the content shown in the yarn lock file section. This is an anchor link that's going to scroll down to the bottom of the page. Boom! You probably saw my little scroll bar scroll about a third of the way down over here on the right. And here is this giant yarn lock file. So let's just go ahead and grab this monster, copy that file to my clipboard, flip back to my project, put my cursor right there inside the contents of the file. We're not even going to read this file, but I can already tell that we have a whole bunch of string decoder version 1.1, some kind of safe buffer 7. You can tell that we've pinned very specific versions of all these dependencies. It looks like 430 lines. Gosh knows how many dependencies we just added to our JavaScript application. All right, great. I think we're getting very close. I'm going to hit back to use the back button in my browser to go back to where we were just reading here before I click the anchor link. And I'm going to go to step 3. I can go to build pipelines and confirm that the latest pipeline completed successfully. So now that I have all of the files, in the text files I've copied and pasted in to create this pretend JavaScript application, so that we can demonstrate how to triage vulnerabilities, we want to make sure that the latest pipeline has ran. And the way we do that is switching back over to our GitLab project. On the left-hand side, there's a little rocket ship. The little rocket ship is our CI/CD pipeline thing. I'm going to select pipelines. And this is in chronological order so that the most recent run of a pipeline is at the top. And the 2 minutes ago pipeline is next, 4 minutes ago is next, and 4 minutes ago is next. What's important here is that my most recent run of pipeline, this top one right here, is green and passed. If you're doing this tutorial at home and yours is not passed, you can rerun the pipeline by simply clicking Run Pipeline up here in the upper right corner, selecting the main branch, and just hitting Run. So just hit Run. My pipeline has passed, so I'm going to move on to the next step. All right, with a working pipeline, I'm now ready to go on to triaging my vulnerabilities. The vulnerability report provides vital information on vulnerabilities. You would usually triage vulnerabilities according to your organization's policies. For this tutorial, you'll dismiss the medium severity vulnerabilities and confirm only the high severity vulnerabilities. To do this, to triage the vulnerabilities, go to Secure Vulnerability Report. Let's do that. If we head down here to the little shield icon, that's where all of the GitLab secure type features are. We're going to select Vulnerability Report. And, surprise, there are 2 high vulnerabilities, 3 medium, 0 low. Let's go see what the next step is. Step 2, select each of the medium severity vulnerabilities by selecting the checkbox in each row. And 3, from the Set Status dropdown, select Dismiss. All right, so there's a couple ways we can do this. I can certainly do what they told me to do, which is to select 3 medium vulnerabilities, change the status, and dismiss them. But if I'm a clever vulnerability user, I can simply select the medium severities, which will change the view that I have on this screen. You'll notice now that I have no critical, no high, no low, no info, and no unknown, but 3 medium security because only the medium vulnerabilities are showing up. I also know that I can just click one box right there, and I can set the status right here to dismiss. Let's see what the directions tell me to do here. From the dismissal reason dropdown list, select used in tests and add the comment used in tests, then select change status. Okie doke, I can do that. Used in tests, I'm going to add a comment, used in tests, and I'm going to click change status. And now, since those have been dismissed, they are now 0, and they drop off my filter. I'm going to go ahead and select all severities again so I get the full view of all the security vulnerabilities I'm presently managing on this particular GitLab project. Looking back at the directions again, the medium severity vulnerabilities are filtered out of view, leaving only the high security vulnerabilities remaining. Step 4. Select the high vulnerability description. The recommended solution is to upgrade the Fastify package. You would usually investigate this further, but for this tutorial you can consider this vulnerability as confirmed. So let's go take a look and see if we have some high vulnerabilities. I see 2 high vulnerabilities. This first one was detected today. It needs triage, which means no human has looked at it yet. The severity is high, and the description is improper check for an unusual or exceptional conditions in my yarn.lock. Here's the CVE and, of course, 2 more identifiers for the vulnerability finding. CVEs are just public cataloged vulnerability numbers that are given as software vulnerabilities are discovered on the public open internet. All right, and then the second vulnerability it looks like I have, also discovered today. It needs triage. No human has clicked on it or looked at it. With a high severity impact, insufficient regular expression complexity in my yarn.lock file. All right, let's take the first one first and see if we can follow the tutorial directions. It needs triage, so no human being has looked at it yet. Detected 10 minutes ago, and here's the pipeline that detected it. It's going to be the latest run, that pipeline we saw earlier. Improper check for unusual or exceptional conditions. So, description. Fastify is a fast and low overhead web framework for Node.js. Affected versions of Fastify are subject to denial of service via malicious use of the content type header. An attacker can send an invalid content type header that can cause the application to crash. This issue has been addressed in commit FBB07E8D and will be included in the release version 4.8.1. Users are advised to upgrade, so I'm guessing we're going to have to upgrade to a version that's 4.8.1 of the Fastify package or newer. Users are unable to upgrade and may manually filter out HTTP content with malicious content type headers. This, of course, again, is a high severity finding. Here's the project that I am presently working on. The dependency scanning tool found this, and the specific pipeline job scanner was the Gymnasium open source scanner that happened to find this. Just as an aside, GitLab has several different types of scanners for all sorts of different types of languages. This particular scanner, because this is a Node.js or a JavaScript type framework application, was automatically detected that it was a Node.js type application, and GitLab applied the Gymnasium scanner to it to scan for the appropriate dependencies and other troubles in this code repository. If you're writing in a different language, GitLab will automatically detect what language that you're writing in and apply the appropriate GitLab scanner from our list of dozens of scanners that we have from the open source world. All right, so the Gymnasium scanner found this. The location of where the security vulnerability or dependency problem is, it's in the yarn.lock file. That's that file that pins specific versions of third-party libraries and dependencies that we use in Node.js applications. Here's some background links if you wanted to understand more about the vulnerability. If you're a security researcher, we are not going to click on any of those. Here's the list of identifiers, so how this particular dependency was found to be vulnerable. If we click on these, it's going to tell me that it was identified by the specific version in the yarn.lock file of Fastify, because it is widely known on the public internet that this particular Fastify version that's in my yarn.lock file, which in fact is vulnerable, Fastify version 2.14.1, is well known on the internet that this is vulnerable to this particular vulnerability. The solution is to upgrade to version 4.8.1 or above. So basically, this GitLab dependency vulnerability report has literally told me everything as a software developer I need to do to fix this particular dependency vulnerability. I didn't have to go anywhere outside of GitLab. It gave me a helpful suggestion on how to upgrade the version, and I can easily do that. We're going to follow whatever the tutorial directions tell us to do just to stay on track. But had we not had a tutorial and we were working day to day, as a developer, I could take this advice and simply upgrade my Fastify package, test my application, make sure it still runs correctly, and then deploy it. Going back to our tutorial directions, it says to select the high vulnerability description, the recommended solution is to upgrade the Fastify package. I agree, that's exactly what it said. You would usually investigate this further, but for this tutorial, you can consider this vulnerability as confirmed. So since we've confirmed it, let's, step 5, select from the status dropdown, select confirm, and then select change status. Back over here in our project, I'm going to scroll back up to the top of this particular vulnerability report. I'm going to look for the word status on the upper right corner. I'm going to go from needs triage to confirmed, and I'm going to click change status. You can see this now has changed this to confirmed, and it was confirmed by me just now. Back on our tutorial, we're going to go ahead and resolve the high severity vulnerability. All right, it's going to get a little bit nerdy here. All right, it's time to go ahead and resolve the high severity vulnerability. Only the high severity vulnerability remains to be resolved. From the triage step, you know that you need to upgrade the Fastify package. We do, because we read through the vulnerability report. To fix the vulnerability, on the left sidebar, select Search or Go to find your project. We're already in our project, but we'll go do this. Number 2, in the upper right, select Edit, Gitpod, and open Gitpod in a new tab. Let's go back over to our project. Here's my project right here under the word project. In the upper right part of the screen is a little misleading. You'll notice it's really more, look right here, in the middle right side of the screen is where the edit button is. So I'm going to click edit. I'm going to click Gitpod, and I'm going to authorize Gitpod to go ahead and use my GitLab project. I want to click standard, and under standard, I'm just going to use the standard image they have and hit continue. I'm also going to select auto start with these options for this repository. So Gitpod's cool because it gives me an entire workspace that I can work inside of without having to install or download any kind of software onto my local workstation. This is really great. Gitpod is really great if you have developers that are new to your organization and need to get onboarded quickly without having to spend days installing software or dependencies on their laptop, or Git cloning tons of repositories or projects from your GitLab instance. Heading back over to the directions, step 3, if you're prompted to, select Continue with GitLab and select Authorize, which we did. On the new workspace page, click Continue. In the terminal pane, enter the following command to create a new branch. All right. So for those of you not familiar with some of the command line stuff, I have a bias towards command line Git. So we'll give you a quick tutorial on Git. Git checkout -B. So Git checkout normally switches between branches. If a branch doesn't exist, the -B will create a branch called update packages, and it will create it from a copy of the main branch. So that's all this command does. Switching back over to Gitpod, copying that to my clipboard, you'll notice down here in the bottom right and center part of the screen, there's this cool terminal window that comes up automatically. If that didn't come up on your particular workspace, you can go over to the hamburger menu. So that's the menu in the way up here in the upper left-hand corner. See the hamburger menu? You can go 1, 2, 3, 4, 5, 6, 7 items down to Terminal and select New Terminal. The keyboard shortcut for that, of course, Control Shift, and it looks like backtick. I'm going to use the mouse because there's no way I'm going to remember that. A new terminal window will be automatically spun up inside my Gitpod instance, and I like working with my terminal really big in my screen, so I'm going to drag it up to the top, and I'm also going to drag all my files over here to the left so I can see a lot of the commands. Heading back to the tutorial, I copy the git checkout command to my clipboard, and I'm simply going to click right here. So I have my cursor in the terminal, and I'm going to go ahead and hit paste. Chrome wants me to allow this to happen, and there's the command git checkout -B to create a new branch named update packages as a copy of the main branch. Look at that. Switch to new branch named update packages. So everything I do here should be safe. I'm working on a feature branch, or in this case, it's a dependency security fix branch. Heading back to the directions, step 6 says, in the terminal pane, run the command yarn upgrade latest. This updates the project's dependencies in the yarn.lock file. Let's go ahead and copy that to our clipboard, run that. And if you are not a Node.js or a JavaScript developer, all that does is simply upgrade all the versions inside your yarn.lock file to the latest stuff. That should resolve our dependency problem with that super old version of Fastify version 2, whatever that was. Step 7, in the terminal pane, run the following commands to commit your changes. This triggers a CI/CD pipeline. There are 3 commands any command line person uses. 4 commands that a Git command line person uses on the regular. Git status, git add, git commit, and git push. So we can actually see the status. If I do a git status here, it'll show that I'm working on the branch update packages. The following the following files have been changed, but these changes have not yet been staged or added for commit. When I ran that yarn command to update the versions, it updated all the versions in my yarn.lock file, but it also updated the versions in my packages.json file. So to stage those files for a commit, I have to use git add. That's git add package.json. I can use tab to complete, space, yarn, and I'm just going to hit tab to autocomplete the rest of that. When I hit enter, it has staged or added those for a future commit. And if I do a git status, I can see suddenly we went from red files to green files. You can see that we're still on the branch update packages, so I'm in a feature branch. These changes are ready to be committed because they've been staged now. I use git add, and I'm ready to commit them. So what do they suggest I use for a commit message? Git commit -m gives a commit message. update package versions. That's a great commit message. We'll just paste that in there right there and commit done. To get those up out of my Gitpod instance and up to my GitLab.com project, I need to do a git push. So we'll just do the git push. If I copy that to my clipboard, we'll do the git push. And just like that, we've pushed up to GitLab.com into my particular project. It also detected that this is a new branch up on the GitLab.com project that I have open. And that package is, that branch, that feature branch is called Update Packages. Switch to the GitLab browser tab. Go to Code Merge Requests and then create a merge request. That's a little deceiving. So how do I get back to the tab? Because I didn't open a new tab with my Gitpod. I could probably just use the back button. In fact, there it is right there. And if I go take a look at the build pipelines, by default, when I do a commit on a project, it automatically triggers a new pipeline. So let's go ahead and follow the directions here to switch to the GitLab browser tab and go to Code Merge Request and then create a merge request. On the new merge request, we'll scroll to the bottom and select Create New Merge Request, and we'll be off to the races. So we're doing 9 and 10. So if I go to Code and click Merge Requests, I can create a new merge request anytime I want here in the center of the screen, but if you look up here at the top, GitLab knows that I just created a new branch called Update Packages, and it prompts me with this big green box that it's very likely this is the next thing I want to do. GitLab, you're right, this is the next thing I want to do, so I'm going to use the big blue button to go ahead and create the merge request. All right, in the new merge request page, scroll to the bottom and select Create Merge Request. Wait for the merge request pipeline to complete. Cool. I'm just going to scroll to the bottom, create merge request. Now with a merge request and a feature branch, which are now linked together, you'll notice that a new pipeline has started. And we're going to have to wait till this pipeline finishes. All right, my pipeline finished, and I just simply refreshed the particular tab I was in by clicking the refresh button. And we can now see down here that we are ready to merge. Let's see if the directions tell us to do that. Refresh the page, then select merge. Sounds good, merge. Wait for the pipeline to complete successfully. Then go to Secure Vulnerability Report. All right, let's do step 12, which is wait for the pipeline to complete successfully. And the way I can find my pipeline here is I can either see it here on the merge request right here. That's the pipeline number that's running. I have a bias towards using the navigation on the left-hand side of GitLab. So if I collapse code and I go back down to my rocket ship and I click pipelines, the bonus of going this route and using the left-hand navigation is if I have other developers working on the same project, I can see other pipelines that are running at the same time my pipeline is running and see if other colleagues are also working on their own feature branches on this particular GitLab project. No one else is working on this one, it's just me. And you can see that my merge branch pipeline has just passed. So I can cruise back over. We have now seen the pipeline complete successfully, and we know it's successful because it has a green passed right there on the pipeline status at the top. Let's go to Secure Vulnerability Report. So again, secure on the left-hand navigation is the shield. So there's the secure shield. Second item down, Vulnerability Report. And if I select the high vulnerability description, a banner confirms that the vulnerability has been resolved on the main branch. You would usually confirm that manually by verifying the version of the Fastify package specifying in the yarn.lock file. For this tutorial, you can skip the verification step. We're not going to. We'll go verify that, make sure it got updated. So let's go take a look at the high vulnerability description. Let's take a look right here. At the top it says vulnerability resolved in main. The vulnerability is no longer detected. Verify the vulnerability has remediated before changing its status. Again, if we just wanted to follow the directions, we would of course resolve this because this was resolved. But let's just double check, right? So if I go under code, repository, I can go look at my yarn.lock file. I can go look at the raw output of it right there. And I can go look for the Fastify package. You can see the Fastify package is now at version 4.23.1. No longer version 2, no longer super old, now is current. Great. Verified that was easy. So let's head back over here to my secure vulnerability report, and we can see that this was resolved in the main branch, and so we can go ahead and resolve this thing. I'll just change the status to resolved. You can see a little green resolve just pops up there, and if I switch back over here, in the status drop-down list, select resolve, then click change status. Go to the secure vulnerability report. You should now see no vulnerabilities listed in my vulnerability report. Let's go find out. Secure vulnerability report. Looks like I still have one vulnerability here, so let's go see what's going on with this. Insufficient. Oh, I don't even need to read past this. Look at this. Vulnerability has been resolved in main. This vulnerability is no longer detected. I bet because we upgraded the version of Fastify, I've automatically resolved whatever this is, and I don't even need to read what this vulnerability is. So let's go ahead and resolve this as well. And now the tutorial should be right on the money. So here we go. No results when looking at all of these various vulnerabilities. All right, back to the tutorial. Test vulnerability detection in a merge request. You now know how to triage and resolve vulnerabilities. Now, to see how to detect new potential vulnerabilities in a merge request, add a dependency known to have vulnerabilities. All right, I'm guessing we're going to add another package that's also super old. Let's find out if I'm right. To add a new vulnerability, switch to the Git pod tab. If this is timed out, select Open Workspace. We can flip back over to our project. If I click the project, and if I click the edit, again, look right here, edit right there in the middle of the screen. I'm going to flip over to Git pod. This time I'm going to hold down the command key and do that so that it opens it up in a new workspace for me. Gitpod remembered what I was working on, even though I hit the back button and browsed away from it a few minutes ago. It kept my terminal window open. It kept the command history of stuff that I had been typing before we just simply hit the back button. Isn't that nice? Gitpod's pretty nice. All right, so in the terminal window, we're going to run these commands: git checkout main, fetch origin, and rebase origin to main. So we'll switch branches over here, paste those commands. I'm going to allow Chrome to do that. All right, my current branch main is up to date. I like seeing that. In the terminal pane, run the following command to create a new branch. Git checkout -b to create a new branch, add dependency from the main branch. All right, paste that command in. I've now switched to a new branch called add dependency. All right. In the File Explorer sidebar, select the package.json file. Okay, that would be this file. I'm just going to double click on that. Add the following line to the dependencies section of the package.json file. Axios 0.21.0. So not even a full release version, a 0, still in a beta testing type version of some package. All right, so I'm just going to add that right here in the middle of this set of stuff because it came with a comma. And in JSON, I'm going to need package name, value, version value, comma, package name, version value, comma, and then package name, version value. The last item in a list does not get a comma. So I'm just going to paste mine right here in the center so that we don't have to worry about getting the commas wrong. In the terminal plane, run the following command to install the dependency added to the package.json file. Yarn install. So down here in the terminal pane, yarn install. All right. In fact, look at that. Yarn even knows that a critical vulnerability was fixed in a newer version of this Axios package. In the terminal pane, run the following commands to commit your changes. This triggers a CI/CD pipeline to run in GitLab. Same git add, commit, and push. So we'll just go ahead and copy and paste that into our terminal here. Outstanding. So you can see we've uploaded to my GitLab project that I'm working on. It detected a new branch called add dependency. So we can switch back over to the GitLab browser tab, which I still have open. And we're going to go to code merge request and create a merge request. Sounds just like the same thing we did last time. I'm going to click right here and go down to code, merge request, create merge request. On the new merge request page, scroll to the bottom and click create merge request. Done. Wait for the merge request pipeline to complete, then refresh the page. The merge request security widget warns of new potential vulnerabilities. These vulnerabilities exist only in the add dependency branch and not the main branch. So here's an important distinction. This second go around at dependency management is trying to illustrate the idea that we have a non-vulnerable mainline branch of code, in this case Node.js or a JavaScript application, that is not vulnerable. Then me, a developer, goes and creates a branch called add dependency, and I inadvertently add a dependency of an old package that has security vulnerabilities. GitLab detects that I have added that package and that package is vulnerable and allows me to resolve those vulnerabilities without it ever impacting my mainline branch over there. So I'm resolving security dependency troubles on my feature branch. There's a couple of impacts that happen because of this approach. First, I'm not changing the risk security posture of my mainline branch. I'm only introducing vulnerable code on my feature branch, and I'm going to resolve that security problem before it ever sees the mainline branch. So if you have a legacy piece of code, perhaps a large legacy software project, that you're trying to make the security dependency risk posture of that particular project get better over time, that is what GitLab's approach here helps enable you to do. So every commit on your mainline branch over here is a commit that gets you closer and closer to being more current with your dependencies and more secure. All right, so we're going to follow the directions. Wait for the merge request pipeline to complete. Looks to me like my merge request pipeline passed and it's completed, and I'm ready to merge. We're going to see that the merge request security widget warns of potential new vulnerabilities. Oh, look at this. My merge request here does tell me that security scanning detected 2 new potential vulnerabilities, 0 critical, 1 high, and 1 others. I can go click on the full report to see what those are. I bet that's what it's going to have us do. Now you know how to detect vulnerabilities in application dependencies and triage and resolve vulnerabilities and detect new vulnerabilities in a merge request. End of tutorial. That's really disappointing because I love resolving security vulnerabilities. So let's go resolve this, shall we? All right. Incorrect comparison and server-side request forgery. Let's go look at the high vulnerability, because if we resolve the high one, we might resolve the medium one automatically. All right. Incorrect comparison. Axios is vulnerable to inefficient regular expression complexity. This has been detected using the Gymnasium scanner on this project that I'm working on. The file it detected me adding this was the yarn.lock file, and the vulnerable package is this Axios 0.21.0 package. The solution to it is to simply upgrade it to 0.21.2. We can do that, right? We did this before. So all I have to do is that same package. If I switch back to my Gitpod instance here, that same package 0.21.2, that probably will do the trick. If I do that same set of steps, that yarn install and the, git add and the git commit and the git push, I bet I will have resolved this dependency. Now, because I already have a merge request open that is associated with this feature branch that I'm working on, the merge request will automatically run a pipeline and pick up that I made changes on an open merge request to my commit history. Let's go take a look. So if I look back at my project here, I cancel and I head back over to code, merge requests. I have one open merge request called add dependency, and it'll tell me that I just made a commit just now. Once this pipeline completes in a moment, we're going to see whether or not this is still vulnerable. While we're waiting for the pipeline to run, I can click the Changes button and see what changes I made. Oh, look at that. I updated the Axios package version to the non-vulnerable version, the 0.21.2 version. So that should resolve my security dependency. I'm not even going to look at my yarn.lock file, although this won't be a surprise. It updated the version to match the package.json file. If I go back to my merge request and refresh the page, I would bet that my security scanning now has a green checkbox and says security scanning detected no new potential vulnerabilities. And I'm ready to merge into my mainline branch. I have full confidence that after clicking merge to merge my feature branch, add dependency, into the mainline branch, that I have not brought the security posture back in any way by adding this new package. I've not introduced any new vulnerabilities. I've not introduced old crusty Axios package, whatever that is. And I know that overall, if I take a step back, my mainline branch is not going backwards. If anything, it is the risk posture is staying the same or is getting better after every feature branch that I commit to my mainline branch. The merge request in the demo you just saw helps me ensure that the behaviors that I am doing are contributing positively to the mainline application branch of my application. Okay, that's it for this particular demo. Up next, in the next part, we'll read through the academic paper called Dependency Scanning together. We'll see you on the next one.